Hi everyone, thanks for still staying, and I hope you have at least some energy to listen to the last talk. And in this presentation I hope to give you some overview of the things that we're doing in Booking, and to share my experience in implementing machine learning models in production. And I will be happy to share with you the experience that we get and the challenges that we found, and also to provide you some solutions. So hopefully if you will face the same challenges, you will have a few ideas of how to work with them. So for those of you who don't know what Booking.com is, Booking.com is the biggest travel company in the world, and as a part of the Priceline Group, we are 7th biggest e-commerce company. And we have a headquarters in Amsterdam, but we recently opened an office in Tel Aviv. So in case you're interested in IT opportunities here, we are hiring a lot of people now, especially data scientists, backend, and any other IT positions. And Booking.com is operating in 220 different countries. We provide support in 43 languages. We have 15,000 plus employees, and we have a very big data science community inside of the company. We have more than 100 data scientists. I think it will be close to 180, something like that. We have data science applied in all possible areas in Booking, like in marketing, in recommendation systems, in customer service. Wherever you think of, we have data science applied there. And we have all different roles, and we participate in different conferences and meetups. That's about Booking. And the first thing that you can think of, okay, you have 180 data scientists, enormous amount of data. What kind of challenges you can face? Just run logistic regression and your problems are solved. Actually, the first and the biggest problem that we have is the fact that we have a continuous cold start problem. What do I mean by that? So maybe those users who have used Amazon, they know that you come to that website once every few days or maybe a few weeks. But for Booking.com, those people who come to make a booking, most of the people usually don't travel like every week or every month. Sometimes you travel once per year, twice per year, and it can be very different trips. Once you go with your friends, the other time you go for a business trip, and then most of the time that you come to our website, you forget to log in and you figure out that you should do it only at the end of the process, only to get an extra discount. That makes a lot of challenges, because standard applications of machine learning that you can think of like maybe a good recommendation system based on your previous history, might not be that applicable. Okay, what then? Why do we have 180 data scientists? Why do we need these people? Actually, because there are a lot of other areas where you can use machine learning, although you might not have a lot of information about the user. So first of them is, for example, content summarization. So you come to Booking.com, you click, OK, nice hotel, and then 300 reviews. Should I read all of them? No. Instead of that, we use nice NLP techniques and we summarize everything. 300 users said that it was a wonderful hotel. Others said that the breakfast was bad. Another application is that we provide content evaluation for you. You come to Tel Aviv, you look at 300 different hotels, which one is actually a good one, the price that I pay versus what I will get. And we already have an answer for you. We have a badge that says to you, good value for money. So no need to search for it yourself. What we can also do, we can try to segment our users. For example, we can predict whether the user will be flexible on dates. And then if we know that, we can say, okay, maybe you can go 1 week later, and then you can get 50% cheaper options. So actually a lot of things where you can apply machine learning without even knowing a lot about user. However, as soon as you start clicking more buttons on our website, we actually know more about you, and you're becoming warmer. So we can make better predictions, and we can serve you more relevant information. So, sounds great. Now we know where to apply it. What's the problem? Even if you have an enormous amount of data and good ideas, it's still quite challenging. So the first problem is the data. Although you can have a lot, the data that you have might not be the one that you need. So let's imagine you have a very simple problem. Your product owner comes to you and says, predict whether the user wants to have a breakfast or not. And then if yes, we will display this information everywhere. Breakfast for free, best breakfast in Tel Aviv, like users rate this breakfast as the best in Israel. Well, okay, I have the data, I'll just say 0 when user books something with a breakfast, no otherwise. Okay, and I'll have my model. Actually, what we are trying to target, from all our users, we want to take the ones who wants to book a property with a breakfast. But what we observe in our data are those users who made a booking. And an intersection of them is those users who booked it with a breakfast. While the users whom we want to help are the ones that didn't make a booking, because for them, we actually wanted to say that, oh, hi, there are options for that. And we don't have the data for that. What we can say is, okay, we can train our model only on those users who made a booking and say, those who made a booking with a breakfast, this is a positive example, and those who didn't make who made a booking without a breakfast, these are negative examples. But then we make a very strong assumption that those users who made a booking and those who didn't make a booking are the same users, and the distribution of the data is exactly the same, which might not be the case. So this is a case of when we have a lot of unlabeled data, where we don't know whether users wanted something or not, and a small portion of them where we actually have the data. So in that kind of problems, you can call them semi-supervised learning problems, and then there are different approaches depending on the types of missing data that you have that you can apply there. So you can either try to identify from those unlabeled data which examples are negative, or you can try to say that everything that is unlabeled is a negative example, and then you put a weight on top of it. Or you can try to distinguish labeled from the unlabeled data, which are positive and negatives, and also apply some fancy algorithms. And actually, there is a very nice paper about that, how to do that, from NIPS. And also, if you read it, immediately Python code how to apply it in real data. Okay, we try to do something with explicit signal, but what if we don't want to use this, but maybe we have some other data about the users that can tell us what user actually wanted. And one simple solution can be, okay, let's not look at the users who made a booking, but let's look at the things that users were doing while searching. Maybe those users who clicked for a filter, I want a breakfast, these are the users who wanted a breakfast. Okay, that's a perfect solution. We don't need to reduce the sample of our users. The problem there can be that although at some point in your user search journey, you say that you want something, for example, I definitely want a spa, what you end up booking is something different. And that was actually not a critical criteria for you to have spa, sauna, I don't know, and a 3-star Michelin restaurant in a place. You can also live without it. And then by displaying that kind of information wouldn't help the user to find the best property for him or her. So this is another thing that it is a bit hard to understand what kind of information from the user interaction actually leads to a decision. And in that case, you might maybe think of, maybe we can consider only those users who did not unclick this filter as those users for whom it was actually important or not. And maybe you have some other ideas about that. Another problem is that as a user, when you come to a website, you have a long journey. And we try to collect the information about you during this journey. So I try to search a place in Amsterdam. I start exploring. I say, okay, I'm to guest one night, Amsterdam, whatever. Then, by the way, I actually have one child and I want to stay for 2 nights. Oh my God, the prices are so expensive. Amsterdam, no, I'm going to Haarlem. It's like 50 euros cheaper. And I make my booking. So at the end, what you have, the information that you have about users is like, we have features about number of guests, number of nights, place the user wants to go, but these are different things. And when you want to build your model, you need to make a decision whether you take all this information. Do you want to take only maybe the things that user inserted at the beginning, or maybe at the end, because then the user actually knew what he wants to? Take a mode, take, I don't know, a logarithm out of it. So unfortunately, there is no right or wrong solution for that, because it will also depend on how you implement your model. So if you want to say that for every user that joins the website, I want to make a prediction immediately and then never change it, then maybe this is the best choice because you want to optimize based on that. Or maybe when you say that, okay, as soon as user makes some interactions, I want to update my prediction, and then we'll change the classification value every time so that I will show relevant information differently. And then you actually need to do then you want to do it for a mode so that most of the time I will show the right prediction. So that's again a decision. Okay, the other problem, modeling. Let's imagine that you have a very simple thing. You want to predict which are the most relevant hotels for the user. Okay, I have the history of the hotels that user have seen, and then I decide, okay, I just make a binary classification and say everything that user booked is a positive example, and the rest, what he didn't book, is a negative example. And that also might sound like a very simple problem. However, there is a very strong bias that you might not directly think of. So the probability that the user will book the first hotel on the top is actually higher than the hotel that we show on page number 33. Just because the user doesn't have time to scroll through all possible pages and all possible results. And the deeper and the lower on the page the hotel is, the lower is the probability that the user will click on this. Although the relevance of this hotel on the bottom might be extremely high and way better than of the hotel that is on the top. And this is called the position bias. And what we want to do, we want to learn it from the data so that we can decompose two things. To estimate the probability that user will book it is the probability that user will find it relevant, but also that the probability that the user will click on it, given the position. So there are some standard solutions that literature proposes. One of them is randomization of your traffic. So you just randomize your search result list for all the users, and then you see what was actually clicked, and then you learn this bias. But can you imagine what kind of problems can be with this solution? You start showing random properties for the user, and then you might show something extremely relevant, and then users just get pissed off. And then they say, okay, I'm not going to use this website. And then this is a problem for the company. But a very nice paper have recently been published. It was published only 2 weeks ago. And there they were showing that although the best option is to do this by randomized randomizations, but you can also try to approximate this position bias even from the observational data, although it wouldn't be necessarily the exact thing, but you can save some money and not make your users disappointed. So a very nice paper how to learn this position bias from the data, and some Python code how to learn that kind of things, problems that are called learning to rank in Python.
That you don't want to randomize it completely because it may discourage the user. Instead, you're using some other technique, but I didn't quite understand what this technique does. Does it use user data at the data set of the hotels?
No, it considers all the different user searches, behavior, and then the clicks that user made. And then, so I don't go into the details because it's quite complex, but you also compare the relevance of the clicks. For example, one interesting thing is that the fact that user have clicked on position number 2 but haven't clicked on position number 1 kind of may suggest you that position number 1 was not that good, but it doesn't tell you whether the position number 300 wasn't good enough for the user. So this is one thing. There is a kind of a pairwise matching, but then also based on this pairwise matching, if you have a lot of data, then you can try to estimate some parts of this position bias using EM algorithm. So this is quite complex, but with a big data, you try to estimate at least piece of this position bias.
Having tried how bad organization.
So bandit algorithms also mean that you randomize some parts, right? So for those people, for those options for which you don't know, you kind of put it on top and then you try to learn something, which still means that you might lose some of your traffic because this is something where you actually not sure, and then it can have negative effect on your metrics as well. It's a possibility, but it's again closer to the randomization option, which is a valid solution. The other problem is that sometimes we think that we make a great model, but what we like to say in machine learning is correlation is not causation. So what we predict might not be that the user intent, but what the user had to do because he didn't find what he wanted. And let me give you the same example. So we want to predict whether user want to book a property with a breakfast. Okay, I made a model, AUC 0.8, I'm super happy, I made a great job. But actually, one of my main features is city where user goes to. Why would it determine whether user wants to have a breakfast or not? Well, maybe, but there is something there. But then I looked at the data, and what I saw is that, for example, in St. Petersburg, out of 2,000 properties, 75 of them do not have an option breakfast ever, because these are just apartments. And in Palma de Mallorca, 70% of them have breakfast included by default. So whether you want it or not, it will be just there. And then this is an example when maybe we are not modeling the user behavior, but just the fact that if you want to book something in St. Petersburg with a breakfast, while you're scrolling for 2,000 properties, you haven't found the right option. And in that cases, the first thing that is good to do is try to analyze what your coefficients in the model means. And the other thing, maybe you can think of a different setup so that the comparison will be fair. Maybe you can think of maybe narrowing down your sample to only the users who saw both options for one hotel, like where hotel or property had both having breakfast or not having breakfast, but then trying to extrapolate it based on some kind of weight. There can be options. So the main problem is that we try to actually predict what user wanted, what user had to do. And then the solution here is to analyze the data and try to, again, dive deeper into the biases that can be there. Eventually, even if you have thought about all possible biases in your data, still the last thing that you need to do is to try everything in the experiment. And that's what we do a lot in Booking.com. So every model that we want to introduce, we test it in A/B testing. So we split our users. Let's say this will be group A, this will be group B. We'll have our previous model, that group will have our new model, and then we try to see whether there is a significant difference in user behavior between these two groups. And then we have really a lot of experiments that we run all the time, but then it tries to help you. If you see that there is no difference in user behavior, maybe you haven't thought about specific biases, and then they're still there, so you're not predicting what you want. Or maybe your hypothesis that user might ever want a breakfast is just not a very good one. So the summary is that there are a lot of biases in data. There are no golden rules how you can extract all of them, but just by knowing some of them can actually help a lot. And try to analyze your model, not just say the model performs well. And even if the model performs great, you should still test it in an experiment. And try to start with simple experiments, simple models, test it, and then learn what was the constraint that you didn't take into account. And thank you very much. And maybe you have some more questions here. Yeah?
So when you train a model, it's specific to a particular country, or is it ready for as a whole, actually, for all the countries?
So because we are working with 220 countries, usually we make the model for all the countries at the same time, where the country is a feature. But depending on the topic, if we think that this is very specific to this country, maybe you might think of that you need to do a very specific model. But usually we try to scale it, and so that model will be just a country will be just a feature. Any more questions?
What kind of models do you use? Do you use a graph sorry? Graph network. How do you manage the features for the models?
What do you mean by how do we manage the features?
For example, there is a classification model, and there is a graph for network that you have a start, initialize, and then.
So your question is like, how do we collect the features or the information about the user?
How you know what is the start point for customer?
Well, as soon as customer joins our website, that's a start. And then we start to show, we run very many models, and then every model has different features that it uses, and then we have different models in different places, so user sees these models. And then if user behavior changes, the outcome of the models can also potentially change. Maybe sometimes not, but it depends on what is the setup of the model as well. You can also change the outcome of the model dynamically when the user behavior change. Okay, thank you very much.